Hello everyone, welcome to 2 minutes coding, and today we'll be solving number of provinces. It's a simple graph question in which we have to find the total number of provinces, aka the number of connected components in the graph. Okay, so the question is very simple. There are two possible methods to solve this question. One, which is the easier, I wouldn't call it easier, but more like the less optimal method. It's the BFS or the DFS, and the more optimal method is the DSU, the disjoint set and union. So for this video, we'll be covering the BFS and DFS, and for the second method, I will have a separate video. Okay, so for BFS and DFS, we'll have a simple visited array as well as an adjacency list of the nodes in which they will be showing connected nodes with each other. So we'll just run a simple DFS and a for loop for each of the single nodes just to make sure we are covering all the components. Okay, so we'll run a simple for loop from let's start from node number 1. Okay, so the node number 1 visited becomes 1, so visited of node 1 equals to 1, and in the adjacency list of 1 there will be 2. So we now check if visited of 2 is already existing. So if visited of 2 is true, no it's not. So we'll move to DFS of 2. Now visited of 2 becomes true, and then I will check, is there anything in the adjacency list of 2? There's nothing, so the DFS gets completed. Once the DFS gets completed, we'll run a counter. So this was the first time the DFS got completed, so we have total number of components equal to 1. Next, the for loop continues. We check for 2. Oh, the 2 has already been visited, so we don't need to do a DFS for it again. Next in the for loop is 3. So we check, is visited of 3 is true? No. Then we do a DFS on 3. There is nothing in the adjacency list of 3, hence the DFS is over, and we increase the count from 1 to 2. So now the count is 2. There is no more elements left, so all the nodes are done. The count of the number of components is 2, hence the answer is 2 provinces in this question. So that was it for this question, guys. The time complexity is equal to big O of V plus E, so which is number of vertices plus number of edges, and same goes for the space complexity. It will in worst case be all the number of nodes. So big O of the number of vertices is the space complexity. So guys, this is it for this video. We'll meet in the next one.